Hi, everyone. I'm Seven Investing founder Simon Erickson, and we are continuing our interview series here this morning. We're going to be talking about healthcare, which is an industry that's going through some very large changes right now. I'm excited to welcome Donald Brown. He is the founder and CEO of LifeOmic. LifeOmic is a company that's running a cloud-based platform to improve the health outcomes of individuals and organizations. Don, thanks very much for joining Seven Investing here this morning.
Oh, nice to be with you.
Don, we'll talk a little bit more about LifeOmic's business and the specific technologies that you're using a little later on, but maybe let's start at the 10,000-foot level. You founded the company about 5 years ago, and you've seen some big changes taking place in healthcare. Can you tell us about some of the biggest changes you see in healthcare right now, and also what inspired you to found LifeOmic?
Well, yeah, I think it's the same answer to both questions, and it's really the way that healthcare is becoming an information science. I went through medical school back in the 80s, and medicine was very much an art as much as a science. It was really predicated on having a physician who could memorize vast amounts of information and then look at you, as an individual and quickly assess what was going on and come up with a diagnosis. And physicians really prided themselves and were trained to deal with as little data as possible. It's kind of odd in healthcare. There's been this love-hate relationship with data. In other disciplines, in the software industry, the more data, the better. It doesn't have to be clean. It doesn't, just give us the data and we'll figure it out. I think Google proved that to all of us. But with the advent of the Human Genome Project, with the rapid decreasing cost of DNA sequencing, lots of other technologies, now we're coming to a point where healthcare has tremendous amounts of data that it can use to act in a more scientifically rigorous way than has been the case in the past.
Well, I went on the App Store last night. I downloaded the Life Extend app that you have, which is a free app, to help kind
Yep.
of the lifestyle and the eating habits. I'm excited
Yeah.
about. My wife is very excited about that too, of course. But that's just a very small part of the business, right? That's the free app, which is great. But LifeOmic is such a more complex organization than that. And I know your flagship product is really the Precision Health Cloud, a
Yep.
cloud-based app that's more for professionals. Can you talk a little bit about who your customers are and what they're paying LifeOmic to accomplish?
Yeah. Well, as I mentioned, healthcare is becoming more and more about data. We can, there's just this explosion of really interesting and valuable data, starting with the DNA sequence, the genome sequence you were born with, and kind of going right on up the line. And so what we did early on at LifeOmic was to build a cloud-based platform that could aggregate all that data. Because one of the big problems in healthcare is that there are fundamentally different categories of data. There's the old school electronic medical records that frankly is just a mess, data in lots of different formats, but it's useful data, laboratory values, blood test measurements, physiological measurements, the medications you're on, the sorts of procedures you've had. So it's really valuable information, but then it needs to be combined with this very different genomic information. We're each of us walks around with about 3 billion base pairs worth of information in each of our cells, and we're realizing that that's tremendously valuable in assessing our risk for different sorts of diseases. And then there's this explosion of wearable data. We're all, walking around increasingly with telemetry, fitness trackers and rings and all sorts of things that can provide moment by moment insight into what's going on with our physiology. So what we did was to build a cloud platform that could aggregate all that information and then build visualizations so that physicians and other healthcare professionals can quickly sift through that information and use it to guide treatment. And so kind of the first use case for that, the most maybe extreme, is cancer. Cancer is increasingly, thankfully, data-driven, because what we've come to realize is that if one of us develops cancer, it's there are mutations that have happened to that genome sequence we were born with, and it's tremendously important to understand those mutations and figure out which ones are driving the cancer. Because some of those mutations are more important than others. And increasingly, we're finding that once we identify the driving mutations, we've got effective treatments that are already available out there. And so our initial collaboration has been with my alma mater, the Indiana University School of Medicine, and some of their cancer teams that are using our platform to aggregate this information and then to identify the driving factors behind cancers, and then ultimately to treat patients and help them live longer.
Sure. And Don, it sounds like healthcare is not a siloed thing, right? Healthcare is a very comprehensive way of looking at a human being. But traditionally, a lot of those systems were siloed, right? They were
Yep.
just looking at medical records. They were just looking at the genome. They were just looking at a specific facet without looking at the entire human being. Is that a fair assessment?
Oh, it's a very fair assessment. A lot of doctors have been kind of caught flat-footed by the advances in DNA sequencing and genomics. In medical school, you learn a little bit of cell biology, you know a little bit about DNA and everything. But if you went to your physician and said, "Here's a flash drive with my my whole genome sequence. Can you look at this and give me some guidance?" They would just look at you like you had landed from another planet. They have no idea. What am I, you're going to hand me 100 gigs worth of information. You expect me to do something with it. And so clearly the answer is automation. Computers are great at sifting through large volumes of information and, teasing out relevant factors. And so that's what we're trying to do, help doctors who, may only have 15 minutes or so to spend with you. So it's wonderful that we have this proliferation of data, but now we've got to provide ways to help clinicians use that data effectively. Because, just as I say, throwing gigabytes of information at your physician, they don't have time, they don't have the expertise to deal with it. And so software tools become critical.
We need to make it more relevant for the physicians that are seeing the patients with limited time on their hands.
Yeah, exactly. And the analogy I use, I've had the pleasure of becoming a private pilot the last 15 years or so. In airplanes, they've gotten really good at creating very simple, what are called synoptic displays. If I'm flying along at 20,000 feet and something goes wrong, I don't have a whole lot of time to dig out manuals or, do a lot of diagnosis. What I need is something that, a flashing light that, ideally with some sort of graphical display that says this valve right here, is malfunctioning. And here's maybe even a suggested workaround for it. And that's exactly what doctors need. So that we're working on that sort of synoptic, overview display that, Simon's cardiovascular system is great. He's a runner, his resting heart rate is low. Don't worry about his heart. His ticker is fine. But Simon's kidney function, based upon what we're seeing, is a little bit sketchy, and so you might want to pay attention to this aspect of Simon. Here's some tests you might run. Here are some medications that Simon is taking that might be affecting his kidney function, and so that sort of sifting through, still relying on the expertise of the physician, but guiding them through this sea of data to figure out what's relevant.
Sure. Don, I'm going to be talking to my doctor very, very quickly about those kidney tests. Great idea. Let's double click a bit on the technology that you just mentioned there, because as growth style investors, we like to look at artificial intelligence. We like to look at cloud computing. We're really interested in genetic sequencing, genomic sequencing. And your company, I'm so excited to talk to you this morning because you've kind of merged all of those together. And if I can just read this directly from your website, because I don't want to mess it up or screw this up, I want to read it directly. But it says the Lifomic Precision Health Cloud was created to break down the silos that exist between current systems. It can integrate genomic, EHR, imaging, demographic, and any other data set, indexing it so that you can effortlessly combine and visualize it in explorations, just like you mentioned in the last answer to my question. I do want to ask about interoperability, because this is something that electronic health records have tried to crack for decades now. It was flooding the information onto the system, but it seemed like it was more provider friendly rather than patient friendly, right? Is there something that you're doing differently than those traditional EHR platforms?
Yeah, and first, you're exactly right. Unfortunately, EHRs have largely been for reimbursement, more for the financial side of the business, the financial side of healthcare, than actual delivery of care. But there has been a lot of work the last few years to develop some standards. One is called FHIR, FHIR. Which I think is Fast Health Interoperability Resource or something like that. But it's a way of structuring that information from electronic medical records so that it's standardized, normalized, so that if we're two physicians looking at blood pressure or lipid levels or whatever, that there's some sort of common underlying coding system for us to use. And in terms of coding systems, there are others like LOINC and SNOMED, some taxonomies that have been developed to try to standardize this information. So we've been able to take advantage of those. We use those standards to encode all our information. We use other modern standards for storing that genomic information. And then, kind of the magic is putting all that into a common index so that a medical researcher can, in the same query, ask about your DNA sequence along with your medication history and your blood test. And that really hasn't been possible before now.
We've seen big tech companies very interested in healthcare recently, right? Google now has a life sciences division, Verily. Apple's got health kits where they're trying to build a platform for consumers to give data from them. But we've also kind of seen a hesitation from a lot of people of giving information to those big tech companies. Do you think it's an advantage being a smaller independent company here? And then also, how are you approaching the data privacy issue?
I absolutely believe it's a tremendous advantage. I think there's a lot of distrust of the big tech companies, and so it's kind of funny, but it does work out to our advantage that as a smaller company, especially one closely aligned with respected academic medical institutions. The IU School of Medicine is actually a shareholder in Lifomic. They own a minority position that we gave them in exchange for access to wide access to intellectual property. But it also gives us a measure of credibility that, we work with these sorts of organizations. We take that very seriously. And so one of the things we did early on was to invest heavily in security. So as a relatively young, small company, we got our HIPAA, HITRUST, SOC 2 certifications in record time. We invest heavily in, you know, intrusion detection, active hacker solicitation. We want to get, you know, white hat hackers out there pounding on our stuff, you know, to hopefully spot problems before the bad guys do. And that's worked out really, really well for us. We also took this stance, you know, in terms of business model early on, that we don't own the data. So we don't monetize the data. We don't sell the data. The data belongs ultimately to the patients, to the users. That's certainly my philosophy. And then to the extent it makes sense for the organization. So, you know, in the case of IU and assembling data sets for their cancer patients, that's IU, the School of Medicine's data. It's not ours. And so that has really helped simplify things, that we're a platform provider. You know, we develop the tools, we do a lot of machine learning, visualizations, you know, data analyses, and that's where we add value. That's what we charge for. And so it provides a very clear sort of separation of concerns that, you know, we don't own the data, we don't want to own the data, and that just makes life much simpler in general.
I think that makes a lot of sense, Don. We just had Spencer Wells on a couple of weeks ago with Incytome, and he just talked about exactly what you mentioned, that was a real challenge for the direct-to-consumer genomics industry, the 23andMe's, the Ancestries. It's just, you know, when you are the product and there's other factors, it makes it a lot harder to get past that hurdle. We're unfortunately in the middle of a pandemic right now. COVID is a very serious situation out there, but I did want to get your perspective on, are there digital tools, whether Lifeomic or other platforms, that you think would be helpful right now to help the spread, to help contain the spread of this disease?
Well, yeah, there's certainly lots of companies and other organizations out there working on contact tracing apps. You know, obviously lots of biotech companies working on vaccines and other therapies. We're really not playing in those areas. You know, we're fairly focused, you know, on, first of all, just assembling these data sets that allow us to understand a person's health. And you know, you mentioned our apps, and it's very true. Our flagship is this, you know, enterprise grade, you know, bulletproof cloud platform that can aggregate terabytes of information for clinical care or clinical research. But along the way, kind of for fun, we developed a couple of mobile apps. I think, as you know, I'm a big fan of intermittent fasting. I went through a master's program in biotechnology at Johns Hopkins a few years ago, and happened upon a paper by a researcher named Walter Longo at USC that kind of blew my mind as to the health benefits of intermittent fasting, kind of down at the molecular level, which is where my interest lies. You know, if I understand the molecular mechanism, I can believe it. You know, I can see. Otherwise, it's just kind of magic. If you just tell me, you know, Don, drink orange juice and you'll be healthy, you know, that's just not very satisfying. I want to know why. What's the underlying mechanism? And that became very clear for intermittent fasting. And so I started practicing it myself and was very pleased with the results. I started kind of recommending it to friends and family. And then ultimately we decided to build a little mobile app. Initially it was a little fasting tracker that would use our cloud platform as the data storage. So it became a little bit of a load test. We figured maybe we would have 5,000 or 10,000 users sign up for it. We've now blown past 2 million downloads for starting with the fasting tracker, and then we followed up with a second app called Life Extend that Yeah, we did a
Right
lot
here.
of, yeah, that's great. We did a lot of research. A lot of it was me personally trying to understand. There's all this literature out there about what's good for you, what's bad for you. A lot of it's contradictory. A lot of it's confusing. But we spent about a year trying to distill out what are the basic things that people can do that we know, that are scientifically established to make a difference in the level of people's health. And I think most of them aren't very surprising. Eating lots of healthy plants. You can still have your pizza and beer. Lord knows I do, but get lots of healthy plants into your body every day. Get exercise. Try to reduce stress through mindfulness sorts of techniques. Get at least 7 or 8 hours of sleep a night, and then watch when you eat. Packing your calories into a confined window of roughly 6 to 8 hours during the day, and then fasting the rest of the time is becoming very clear that that has a tremendously beneficial effect on health. So anyways, we built that little app. We made it easy for the users of that app to go and get an inexpensive blood test or genetic test, load those results up to us. And then ultimately what we're trying to do is kind of what I described earlier, to give you that bird's eye view, that cockpit sort of view of here's your cardiovascular system, your pulmonary system, your renal system, and so on, and kind of just red light, green light, yellow light. That your heart is great, but here's another organ system that maybe because of genetic risk that you inherited, or lifestyle factors that we're seeing the data reflecting some sort of risk, needs to be paid attention to in some way, shape, or form. And so, the underlying concept that again isn't any rocket science, but I think we all know intuitively it's easier to stay healthy than to fix you once you've become unhealthy, right? Our bodies are unbelievable in terms of being able to maintain a healthy state, but if they fall out of tolerance, with diabetes, cancer, Alzheimer's, any of these nasty diseases, it's tough. It's really hard to fix them. And so that's, one of my biggest misgivings about the healthcare system, that so little emphasis is put on prevention, and way too much on treatment. And none of us would operate our cars that way. We wouldn't just drive without changing the oil or tires or anything until it breaks, and then go into the mechanic and say, hey, fix this. We put a lot of effort into prevention because we know that's more cost effective in the long run. Anyways, that's part of what we're trying to do at Lifomic, so that kind of the direction we're going, in addition to working with these big academic medical centers and hard problems like cancer and Alzheimer's, we're also taking the cloud platform and the mobile apps and using those to offer corporate wellness solutions, even kind of personal wellness subscriptions to people to help them lose weight and improve their health, and all those things, hopefully way in advance of cancer or serious disease.
Don, this is revolutionary for healthcare. Everything you just described makes intuitive sense, but the system itself is still treating sick patients, right? We've gotten
Yep.
used to insurance networks reimbursing for checkups. If you're even doing checkups, more often it should go into the hospital because you're already sick and showing symptoms.
Right.
How proactive, okay, if consumers are being empowered to be in charge of their health, which is fantastic, how proactive should they be for this? Is this something that you envision just continually having sensors that are diagnosing things and putting up that red light that you need to go to the hospital? Or is it still a couple of times a year you need a proactive checkup that informs this? How does this work in your mind?
Well, ultimately, in my mind, it should be continuous monitoring of our health by intelligent software systems. You know, as we were talking about earlier, it's just impossible for a human physician to absorb the massive data that we can generate about our health. And it's tough enough, you're just going in once a year, you know, for your annual physical, but that's just, it's not enough. You know, it's increasingly possible now with these sorts of cloud platforms and big data, you know, machine learning algorithms and so on. Systems can be monitoring our health every second of every day. And so there's just no reason for me, say, to wait, you know, a year for my next physical to go in and have something dealt with if something indicates that my body is, you know, kind of running out of tolerance, you know, moving out of tolerance right now. Then I want to know about it now. I would like to address it now rather than wait a year. And especially as these systems become more intelligent, they're just able to spot a lot more problems much earlier than a human physician can. And so I think this is where we're going ultimately. And, you know, with some of the devices, the Fitbits and Oura Rings and others that are available to us, you know, we can have real-time telemetry that's watching us every minute of every day. And as I say, you know, the holy grail is early diagnosis, find a problem before it really is a problem. Let's find it while it's, you know, a trend, you know, maybe an unhealthy trend that hasn't resulted in a disease condition yet. And then it's much, much easier to reverse that trend and undo any mild damage that has been done to that point.
That makes a lot of sense. Before I get to my final question, I would like to say that LifeOmic is a private company, but if it were publicly traded, I would buy this company in a heartbeat. I really wouldn't.
I appreciate it.
I say that truthfully and objectively. Don, I think is really you're just such an incredible learner. You have such a wealth of knowledge you've built that anyone listening to this interview can quickly recognize. Just to brag on you a little bit before I get to my final question, you have a bachelor's in physics, a master's in biotechnology, and a master's in computer science, a medical doctorate degree. You mentioned earlier you're a pilot now also. You also ran a company called Interactive Intelligence. That you just kind of have assembled all of these pieces together into the ultimate company. I'm very impressed with everything you're accomplishing. LifeOmic is definitely a company that's on my radar. Let me know when you IPO so I can be the first in line.
We will make sure you know. We appreciate it.
Yeah, on top of that, though, I really, since I have you here, would love to pick your brain about some of the other trends and technologies taking place out there. There is so much happening, not only just in healthcare, but in software and cloud computing and AI, artificial intelligence. What are a couple trends, Don, that you're really interested in that you see developing out there right now?
Oh, there's so many. It's just it's a wonderful time, you know, especially for me as a guy who you know, went through medical school back in the 80s. It's just wild to see how much has been learned since then. You know, I don't feel like I'm that old, or that, you know, that I went through school that long ago, but I was able to go through that master's program at Johns Hopkins just in the last few years, and it was just mind-blowing to go through stem cells, what's been learned about the immune system, just the fundamentals of cancer and genomic analysis. So yeah, there are so many interesting things out there. I think the last time we talked about technologies like RNA interference, you know, which is really interesting. I've invested in a little company in Boston that's doing really interesting work in protein degradation. Protein degradation, you know, our bodies are protein factories, right? Our cells, that's really the fundamental thing they do. They they take a recipe that's in the form of DNA and they use it to make proteins, hemoglobin and collagen and enzymes and all these things. But now we're starting to realize that we can intervene at different points. One thing just by selectively breaking down proteins. Initially, that whole area was considered kind of a useless scientific field because who cares how proteins are degraded? They dissolve and they go away. Well, now we're realizing that there are active processes involved in the destruction of proteins, breaking them down, and we can now make drugs that can go into particular cells and break down particular proteins that may be in excess and causing a particular disease condition. A famous one is the amyloid protein in Alzheimer's. So it's just a golden age. Our understanding of the immune system, that's for me, that's one of the most fascinating areas. I donated some money to start an immunotherapy center at the IU School of Medicine, and immune therapy is really kind of at the front lines of cancer. We're realizing that we can activate our own immune systems. We don't have to just take really toxic drugs to kill the cancer cells and inadvertently kill normal cells too, that we can activate our immune system that's exquisitely tuned to identify particular threats, whether it's coronavirus in the case of COVID, or cancer. So there just all these technologies, and they've all really been enabled by Moore's law and a similar phenomenon that we're seeing in the cost of DNA sequencing. I think Paul Allen, owner of the Portland Trailblazers, paid something like $100 million to have his genome sequenced in 2001. You or I could do that for a few $100 today. And so those sorts of technologies are really changing everything just because of the insight they're giving us into how our bodies work.
I think those insights are setting up for the golden age of medicine and healthcare in the next couple of years. It's going to be a really fascinating time for your company and for the industry as a whole.
I think so too. I think it's a golden age of medicine, and as I said at the outset, medicine is making that transition from an art to more of a data-driven science. And for a guy like me who's kind of bridged that gap his whole life, it's really exciting.
Absolutely. Well, once again, Donald Brown, the founder and CEO of LifeOmic, joining us this morning from out in Utah. Don, it's always a pleasure. Thank you for spending the time with Seven Investing this morning.
My pleasure.
And once again, thank you for tuning in to this interview. We are here to empower you to invest in your future. We are Seven Investing.